Alright, this video will be super quick. As you guys talk about in classroom, can we have a video? Yes. Okay, so blah, blah, blah. Given a function, we're going to use it. What do we say at the very beginning? Function, whenever you see the x, you put a bucket. Don't say that. Ms. Hong, it's a t, not x. Well, it's my unknown. It's my variable. So whenever you see the t, we're going to put a bucket. That tells us we are going to plug the number in and have fun. We mentioned about we are math people. Initial, because this story talking about the bacteria with the time in hours, right? So you know that the initial, the very beginning, when time started, that will be t equal to 0. So please remember initial, t equal to 0. Initial, the time is 0. So what do we say? Just plug it in. So beautifully done. The t is 0 when you plug this number in. 150, just a number, leave me alone. My base is e, leave me alone. My power is 0.585 times 0. So we talk about that. 0 times everything still be 0. Then what do you see here? You see e to the power 0. Now, this is the definition. The final answer, it is 1 because my what? Exponential function guarantee when I grab that it must go through 0, 1. So whatever you see my exponential function, it always give me the perfect answer 0, 1. That's it. Okay, now just for the definition, any non-zero number, for example, I got -1/5. Okay, this non-zero power this non-zero number, raise the power to 0, the final answer always 1, okay? Now, regardless, you have a 15, okay? Raise the power to 0, the answer, it is 1. 0 to the 0, never, okay? So therefore, because this entire thing, it is 1, so 1 times 150, the answer is 150, cool. Now, plug it in. So this is just tells us about the function, right? Whenever you see in the bucket, you plug in the bucket and then you do the housekeeping and then you got the perfect answer. 16. Well, when there is a given function, we just need to plug it in. Again, when you finish reading, the beautiful of reading, you know that the 5,500 years, it will be plugged in my time. T stands for my time. So do the housekeeping, then done. So far so good? All right, 17. We are talking about the a growth of what? Turtle. So we're talking about the growth of a turtle. But we also give a function. What does that tell us? We're going to use that. Ooh la la. What do you see as a keyword? Initial. So the initial tells me the time is 0. So that's good. So do not overthink. When you plug it in, when t is 0, then you just nicely plug in your calculator. 1 plus 3.62 times e to a power. So the t is 0, so which tells me 0 times everything is 0. Now comes the trouble. E to the 0 power, you know it is 1. When you do housekeeping, what do you got? You got 263 over, now 1 plus 3.62, that will be 4.62, right? So now, can you plug this nicely in your calculator? And then that will be your perfect answer. The next one. Plug it in. I trust your calculation and use your fancy calculator. You shall get the answer. Now, in classroom time, we get a bonus plus 1 point, right? So when we talk about the limited size of the population of the turtles, right? So we mentioned about, hey, you are given a function. What will be this function give you an inspiration? The limited size, kind of like what will be the small size for me to go? So the maximum, the minimum, kind of like the keyword we're looking for. So the 263, as you can say. Miss Hong, that is the limit. Okay, then you got it. So this will be our perfect answer. And that's it.